All right, so where we're headed eventually, so this chapter is on applications of integration. There's a couple other methods for solving integrals that, if you don't know how to do it besides U substitution. One of them is called integration by parts. It's not technically part of the AB curriculum, but we'll probably deal with it at some point just for funnies. But for right now, we're just going to go with our straight up integration or U substitutions and see all the fun things that we can do. So eventually, we're going to use integrals to find volumes of fun things like this. Okay, so we're going to take like a curve, and instead of just finding the area between that curve and the x-axis, we're going to take that curve and we're going to rotate it around the x-axis, which is going to create a three-dimensional object, and then we're going to use integrals to find the volumes of those three-dimensional objects. So that's pretty awesome. Okay. But before we get to there, we have to do something much easier, which is finding the area between two curves. Okay, so yeah. A sphere? Yeah. But what if the curve is not a semicircle? What if it's a curve that looks like this? Then when you rotate it around the x-axis, you're going to get an irregular shape. And so you can't just use the formula for the volume of the sphere. You have to use calculus to figure that out. We're going to find the volume of some weird shaped blobs, yeah. And they do get pretty weird shaped. Yes. Okay, anyway, but before we do that, we're going to find the area between two curves. And that is super, super easy, and that's why you're going to enjoy today. It's actually going to probably be good practice of what we've been going over the last couple weeks. Technically, we have been always finding the area between two curves when we've been doing these integrals. But the one curve has been this function right here, and then what's the other curve that we've been finding? Nope. The x-axis, yeah, which has an equation of y equals 0. So nobody cares because it's just y equals 0. If we want to instead find the area between this curve and another curve right there, all we have to do is just subtract top curve minus bottom curve. Doesn't even matter if they're both above the x-axis, because that should kind of make sense to you. If I have this curve here and I want to find the area between that and that curve there, what I'm doing essentially is I'm finding the area between this top curve and the x-axis, right? And then I'm subtracting then I'm subtracting the area between this curve and the x-axis. And then that answer will give me the area between those two curves. I'm not a genius. Kind of, but all you have to do is just just do the subtraction first and then do the integral. All right, so this is the formula. I don't know what kind of notes you usually take. So that's the formula. The area A of a region bounded by the two curves y equals f of x and y equals g of x, and then from x equals a to x equals b. This is important. F of x has to be bigger than g of x everywhere. It's just the integral from a to b of f of x minus g of x. Okay, and then this is what I had mentioned before. We've actually been doing this the entire time. If the second function is g of x equals 0, that's just the x-axis, and then that's what we've been doing. All right? Okay, so let's find the area of the region bounded above by x squared plus 1, bounded below by y equals x, and bounded on the sides by 0 and 1. Okay? So I'm going to draw this just so you can sort of see conceptually what we're doing. We don't really need to draw this to solve the problem, but it might be helpful as we're sort of building this idea for you to have a picture in your head. So x squared plus 1, I'm sure you know, is a parabola that's been moved up 1. Y equals X, I'm sure you know, is the line that looks something like that. Thanks, man. This is y equals x squared plus 1. And we're going from 0 to, I'll just decide that this is 1 right there. So we're trying to find the area of that little piece right there. From 0 to 1. Okay? Does that make sense? Okay, so this is exactly what Payson and I were talking about. We're essentially finding the area from 0 to 1 of x squared plus 1. And then we're subtracting from that answer the area from 0 to 1 of y equals x. And then that gives us that little thing that we're looking for. So integral from 0 to 1, x squared plus 1 minus x dx. Yeah? That's the bottom function, yeah. Because they said by the function y equals x. What? I don't understand. What? Do you want to take that one, Tegan? What'd you say, Maggie? Oh, okay. Yeah, I mean, I guess I could call this y1 and y2 and go y1 minus y2, but then I can't, I mean. Okay, so I'm going to simplify first. So I'm going to rewrite this as x squared minus x plus 1. And then I just have to do the antiderivative stuff. What's the antiderivative of x squared? X to the third over 3. The antiderivative of x is x squared over 2. The antiderivative of 1 is x. And I'm going from 1 to 0. I just want to give you a little word of caution. A lot of times we've been plugging in 0 and the answer is just 0. That's not always going to be the case, so don't take that for granted. Make sure that when you plug in 0, that really is what you're going to get. If I plug in 1, I get 1/3 minus 1/2 plus 1. If I plug in 0, I do get 0. Let's see, 1/3 minus 1/2 is negative 1/6 plus 1, so that works out to be 5/6. Okay, so except for that really confusing y substitution that I made at the beginning of the problem, I didn't really do anything different than what we've done before. So if you know how to do a basic integral, then like I said at the beginning of the lesson, this is going to be a pretty easy section for you. It should be. Okay? Do you say wait? What's that? Nice. Okay. So Maggie asks a great question. This one specifically says the area of the region bounded above by this and below by the other one, so you know then to subtract one from the other. This one does not. Okay? This one just says find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. All right? So we got a couple of different issues here. First thing, like Maggie said, we have to figure out who's on the top and then who's on the bottom. And then we also have to figure out where we're integrating from. What numbers are we integrating between? Okay? So now I am going to go ahead and draw the picture of the graph. So this is roughly y equals x squared. What do you guys know about y equals 2x minus x squared? Okay, you know it's going to open down because the x squared is negative. Okay, I disagree that it's going to be skinnier. The number in front of the x squared is still 1, just like the number in front of the other one. No, that's if you multiply. What makes it wider or skinnier is the value in front of the x squared. And since those are both 1, it's going to be the same. What the 2x changes is the X intercepts of the graph. So if I have 2x minus x squared, I need to figure out where this is going to cross the x-axis. So I'm going to factor out an x. So that tells me that x equals 0 or 2. So that means my graph is going to be here at 0 and 2. What is the, how do I find the vertex of that parabola? Right, so right in the middle of there is going to be 1. So if I plug 1 into there, I get 1. 1, 1 is this point right here on my other parabola. So it turns out what we got going on here is this little guy like that. Yes. Desmos would be graphing, just using a different graphing tool. If you want to do that without graphing, without making a picture at all, really all you need to do is set these two things equal to each other. Okay? Because we're looking for the intersection points there. So if I set x squared equal to 2x minus x, I'm going to get everybody over there on the left. Just don't tell Payson. Then I'm going to factor out a 2x. And then that gives me x equals 0 and 1. Okay? So that's a different way that you can find these two intersection points without graphing. Okay? Now let's go back to Maggie's question. How can I tell which one is on the top? We know from my drawing, that I'm going to go from 0 to 1, oh, good one, of the orange one, 2x minus x squared, minus the maroon one, right? Can you guys see that? Okay. Let me ask you this question. What would happen, do you think, if I took a chance, made a guess, and said, hey, this one's first, so I'm going to put it on top minus the other one, and then I did everything correctly? How would my answer be different than if I do it like this? Would be kind of the inverse. It would be the opposite. I don't know if that's what you're getting at. Yeah. It would be the same answer but negative. Okay? So if you do this and you get a negative answer, assuming that you did everything else correctly, which is, you know, a risky proposition. Right. And so that's why you would just make it, right, absolutely. Absolutely. Yeah, that's correct. So if you're not sure, Maggie, which one's on top, you can just guess. And if you get a negative answer, then make it positive. It's a little bit of a risky proposition because you might have gotten a negative answer because you did something else wrong. So, you know. Oh, instead of the one minus the other one, kind of? Yeah, yep, you could do that. Okay, so then this integral is really simple. What's the antiderivative of 2x? X squared. And what's the antiderivative of 2x squared? So, yeah, so 2x cubed over 3. And then I have to plug in 0 and 1. If I plug in 1, I get 1 minus 2/3. If I plug in 0, I get 0. So my answer there is 1/3. Area cannot be negative. So when they're saying what's the integral from 6 to 4, it's sort of like they're saying what's the opposite of the area from 4 to 6. Okay? So no, I'm not going to fall for that. Okay. Yeah. We don't need to use that here because I can take this, I can figure this out without doing that. The only time I need to use a u substitution is if I'm looking at an integral and I'm like, I don't know what the antiderivative of that is. It's too complicated for me to do, so then I try and use a u substitution to simplify it. Okay? All right. Okay, so of course things are going to get slightly more complicated, but we'll save that for tomorrow. For right now, it seems like a good idea for you guys to practice some of the basics. Does that mean you won't be coming to class anymore? Okay. How much longer do I have to suffer? how many pieces